This is problem 40 in chapter 6. In 1846, a major discovery occurred when Neptune was discovered. It was actually predicted based on the perturbations of the orbit of Uranus. So they assumed there was a planet beyond Uranus that was impacting the gravity on Uranus and would change its orbit. So this was a major find in 1846 in which Newton's laws of gravitation were confirmed. Then, after that, there was an assumption that there might be planets beyond Neptune, which would cause Neptune's orbit to perturbate as well. And so this problem looks at the impact of Pluto on Neptune versus the impact of Uranus on Neptune to get a feel for the sizes of those relative effects. In the problem, you're given the distance between Uranus and Neptune, you're given the mass of Uranus, you're given the distance between Pluto and Neptune, and you're given the mass of Pluto. What we're not given is the mass of Neptune. So instead of finding the force of gravity between the two planets, we're going to find essentially little g, which is the gravitational constant times the m of the planet, mass of the planet, m, and the distance between Neptune and the planet as well. And that's squared. So if we look at these calculations, we find out that Pluto has an impact on gravitational impact of 4.6 times 10 to the minus 14 meters per second squared. Uranus has an impact of 9.2 times 10 to the minus 10. Sorry, that's kind of hard to read. That's 10 to the minus 10. And so if we take the ratio of the gravity of Uranus on Neptune to the gravity of Pluto on Neptune, we get a ratio of actually 20,000. So Uranus has 20,000, an impact 20,000 times greater on Neptune than Pluto.